So we wanted to discuss a bit the ideas around machine learning of the future, and this workshop has seen many applications and many directions in which machine learning and data science can develop. And the first question I would like to discuss with you is what are the key topics where you think that machine learning, data science can be useful in supporting humans in solving their many problems? So how can machine learning be a tool for humans to solve problems? What are in the future the key areas where this will be an important tool, and maybe also new, in which areas it will be newly important? So I would like to ask first maybe Professor Hadi from
Okay.
UNPAD. Mhm.
Okay. Thank you, Michael. Of course, machine learning, data science is now a modern technology. While when I was learning machine learning when I was in the doctoral studies, it's very difficult to implement. But now by technological advances, we can implement the machine learning, and of course, we can create a good application related to machine learning. Data science, for the data, we have no lot of data can dig from the internet, or we can ask, for example, my college she has a research in Twitter hate speech, and they have a collaboration with Twitter about checking the hate criteria of the tweets. It's quite interesting that it used, and the data is available, and Twitter gave the researcher the data for searching. So for humans, it's very, very useful. Machine learning and data science. Of course, we have actually it's included in my presentation when I was present my talks. It's we have to be careful with the data and with the algorithms, because we have a black box. Just like we have a black box, we don't know what is inside the black box of machine learning algorithms. For example, in Python or in libraries, it's difficult to. Now we are advancing to what is called an explainable AI. So the AI that is explainable. I mean, it can be described, and we know what is happen in the algorithm itself. And yesterday, I also joined a conference about ethics in machine learning. So in my conclusion for these questions, that the topics of machine learning and data science are very, very many in we can use it. For example, for helping in my field in computer vision, yeah, it's very valuable for object detection, for human detection, for example, what's the last presentation about the quality of the water? If it's visually can be visualized, I mean can be seen by eyes, so we can use camera for detecting the water, etc. So that's very, very helpful if we continue developing machine learning and exploring data science.
Mhm.
So it will be important for humans. Thank you.
Thank you, thank you. So I think we can also ask Professor Dosin what he thinks about this question. And Professor Hardy, he already answered 3 questions, also some key technologies. But you can, of course, later we can come to these questions and in more detail explore them. So I would like to understand in this first question, or we should focus on what are areas where there can be a very big impact of AI technologies to change these areas. So maybe the question should be where does it where it is a game changer in the future, where it is not yet.
Uh, as for me, we cannot imagine what will be next 10 years and what changes our habits and technologies. And like mobile phone was not expected how it changes society. And then next maybe it will be robotics will be less and less expensive, more popular, and in every home. And such technology very fast develops and can be very influential for our everyday work and habits and so on. Then it seems to me that main direction of progress
Hmm.
in impact of robotics on work and home and so on.
Hmm. Interesting.
Seems to
Yeah.
me.
Hmm.
But maybe I should add that data science and machine learning very influential in field of um, decision making and society as multi-agent systems.
Hmm.
Multi-agent systems habits or how to in English activity
Hmm.
very uh, non-linear. We cannot use traditional statistics of such static systems we used uh, to use. Yeah,
Yes.
because it every time changes. It depends of our models. We model society, but society analyze this model and changes. And only
Okay.
machine learning approaches can do with this problem. Uh, it's science of um, holism,
Hmm.
holistic approach. Very
Hmm.
important here.
Also
That
with the feedback loop. Mhm.
yeah, yeah, it's very
There's
important.
maybe something that came to my mind when you said this last point, that society is changed by AI and AI is changing society. It's a bit
Yeah,
similar to when they make this, when people try to invest in the stock market. The way we invest in the stock market to increase our capital will be
yeah,
influence the stock market. And so
but
it's a kind of
yeah,
complex system.
it's big, very big loop, but it
Hmm.
exists small loops like when we know about transportation traffic and we
Hmm.
influence on this traffic because we change our habits. We use transport or not used and so on.
Hmm.
Many loops, different
And to
level.
understand this complexity, we might even need artificial intelligence systems.
Yes, only by means of such machine learning tools we can
Mm.
operate with such data and
Mm.
take into account big loop, these loops. Oh, no.
Okay. So maybe to ask also other participant like Miroslava, for instance, would you like to comment on this question?
Yes, thank you, thank you. It's very good idea, and I can to continue the things of Professor Dawson, and I thought that first step is change myself. It's for every scientist some period when you start to understand this problem more better than it's typical. It's first period it change myself, then create the new um, model, and then model will change society. I hope it's very difficult way for changing in my mind. It's very important to change thinking, own thinking, when then change the other thinking. And I open for collaboration, and for me it's very interesting is the direction of circular economy and green economy, and improving all result from Netherlands and other European countries in Ukraine, especially after they've been in war, and I plan to rebuild Ukraine in the modern way of Europe, and I hope it will. I believe, and I want to get your help for Ukraine, for Ukrainian people, for rebuilding Ukraine after the war. Yeah, and I leave my information about me in this chat, and you can use it and connect for me by email, and look about my publication in other database, scientific database like Scopus, Web of Science, Google Scholar, and you can contact with me by Telegram or by email as you
Thank you. So I think there's also a question in our panel discussion how we can better support each other as scientists in Europe and beyond. So we have Sajivan from Indonesia, for instance, and actually there are many collaborations between Netherlands and Indonesia, but why not also between Ukraine and Indonesia?
Yeah, right.
They have also similar problems, not like you had recently earthquakes that caused electricity shutdowns and many tragedies. Not man-made catastrophe, but on the other hand, the effects can be similar. And I think it's also good to open for international collaborations. And yeah, so and I think topic of machine learning, in a way, it's also to boost the economy because it's something where many new innovative business and companies are built based on modern machine learning technologies. So I think in a country that needs to build up again after a war, it is very important to use modern technology. It's even a chance to do it better than before and to make it, let's say, a power state, power country. I see a country like Estonia, for instance, as an extreme good example for a country that is ahead of all European countries in terms of e-governance. They do almost everything electronically in Estonia. So we can learn from countries who have this innovation drive. But anyway, I wanted to ask, are there others who want to highlight some important topics for machine learning in the future, or where you think that machine learning will make a big change to society in the future that we might not yet see so much yet?
May I propose some answers to your questions?
Yes, of course.
The first question, my answer is the very interesting would be to develop the model of intuitive artificial intelligence, because the logical way is very dangerous for me. The logical way, the strong machine learning, data science, and so on, leads to the some very difficult problems. Remember the theorem of Gödel on incompleteness. We can have some question, some statements that may be not unproved or may be proved. And the artificial intelligence can't solve this problem, and human also. But we solve this problem very simple. We use intuition. Not strong logical, but some stochastic process. It is very interesting to develop some mathematical apparatus to describe at least in conscious the process of intuition in human brain. Maybe it is useful to use some results of Professor Izhikevich networks, and so on.
What is, can you type it? I don't know this professor.
This is a very interesting Billiardaire. That is academic professor, a migrant from the Moscow. And now he is one of the founder of the startup. To everyone. He used some networks that not is binary nodes, but some imitation of neurons, human neurons.
Okay.
And next questions are very simple. We must to develop and uprise the mathematical education. There are many users of machine learning tools, but users don't know how they works.
Yeah, right.
That is why we now must develop so-called explainable artificial intelligence. Explainable for whom? We know how it works. It must be explainable for users.
Okay.
But must we explain how work the computer or TV? Computer and TV is black box. You simple use it at all. And users must not know how it works. User must confident this work, confident this tool. So we must not explain how it works, but we must make confident these tools.
Okay, this is an important distinction to explainable AI, because explainable AI would like to explain to people who don't understand machine learning, and you propose let all people understand machine learning.
I see.
Yes, and teach it already in school, for instance. I would think this is an interesting also point.
I have a wide experience of work with magicians. They don't want anything in mathematics, but they want to confident in my results.
So this would also be question 4, because it's about how young people can prepare for a career in machine learning and data science. But your proposal would then be let more people be educated in this. So,
in my opinion, not before 20. To understand the machine learning concepts, the human brain must be formed. As we know, the human brain closed for forms at least 1901, 1902. So for teenagers, it is not useful.
But there might be some skills that we can teach young people to be prepared to understand computer programs and to understand the procedural thinking.
Of course, for example, probabilistic intuition and probabilistic reasoning. It is very difficult tasks for, at least for young men.
But it will be a key technology, right? I think the machine learning is very much based on statistics and stochastics thinking, even if it's a deterministic method, like Bayesian methods are sometimes deterministic, but the background is statistics.
Yeah, I would like to add something, Michael.
Yes.
Besides explainable AI, now we are facing topics called trustworthy AI. So the AI must be trustworthy. For example, if we apply machine learning or AI to a self-driven car, and then there is an accident, so who will be what is the problem? I mean, who will be accused for this problem?
Accountability.
Yeah, right. The algorithms, the man behind the algorithms, or the car, or who? So it's a problem. So it must be a kind of a nice topics to discuss when we apply machine learning. And there is another technology. Now we are using a supervised learning. So we give data to the machine, and the machine analyze it using the algorithms. But now we are facing a technology called self-supervised learning or unsupervised learning. So it means that the machine can learn itself from the condition. So we don't have to put the data to him or to her. And yeah, it's quite it's scary. Yeah, so the machine can learn from ourselves. Yeah, so that's
by itself.
For itself. Yeah, just like a movie. So it's quite difficult. But the main thing is like Professor Klushin said, we need the ethics for AI, the rules for the AI, so it can be it will be a fair judgment if something wrong. That's my addition. Thank you.
So I think,
can I continue discussion?
Of course, yes, please do. Go ahead.
Professor Vadim Slusar. Regarding first question, I hope and believe that machine learning and artificial intelligence will make our life more comfortable, more safety, and more friendly. But in this time, we have big technology problems in the area. First is old mathematical theory. In my opinion, we should be evolving tensor matrix theory on multi-dimension operation. And the next problem is implementing quantum computing, because we have limitation of computing capabilities, and big problem with training hyper neural networks such as Berta and GPT and stable diffusion, another. In last week, I found new publication from Russian science that proposed quantum neural networks concepts. I hope it will be general ways and approach for future evolving in this area. Regarding question number 4, in my opinion, for this need use a more friendly software, such as Lego constructor for building neural networks without using difficult program such Python and another language. Similar concept used now in MATLAB package. We can use only box and link for construction of neural network architecture. It's very easy, in my opinion. I hope that we will study artificial intelligence in school and maybe preschool for children, because new and jungle gender will be more evolved as me. In my opinion, all approach and all theory neural networks should be open source for all countries. And this problem is commercialization artificial intelligence. We should be improve best practice and international law in this area. Thank you.
Thank you for your interesting remarks, and also the need for computer languages that are accessible for education might solve one of the problems of that was mentioned already by Dmitro Kushin,
Yes.
because we need probably also for children ways to teach artificial intelligence that is not so difficult to learn than we teach it in university. So I think we can combine such answers in the need for some AI languages that are a bit more accessible for young people. I found this an interesting idea. I just summarize the previous comments. So we moved on the discussion, the panel discussion, by discussing all questions. So people commented on all the questions, which is okay. We can continue like this. And I would, if someone of you still also wants to comment on the different questions, feel free to do so, or on a particular question. Maybe you would like to give us an opinion or an insight that you want to share or discuss.
Okay, Michael, I want to answer the question 4. I agree that the machine learning or data science or data mining should be learned by since the children. I mean, for the elementary school, for example. In the sense of application, I know application called Orange Data Mining. It's just click and bring it to the screen. You don't have to have programming capabilities, but you just put the data. If you want the data, get the data from Twitter, from Facebook. Yes, right, Orange Data Mining, right. Yeah, it's quite interesting. So the students can, I mean, the children, for example, can teach, can be taught about the machine learning. Yeah, that's.
Yeah, so this is also interesting that we see from the audience some new tools that can be used, programming languages, but also data mining explained to children by Orange. Is it from the Indonesian word orang?
No, no.
Or is it orange because of the color?
Orange fruit. Yeah.
Okay. So maybe on the question of professional career preparation. So if you think about your students and you would like to prepare them for a career in machine learning and data science, so I find this question myself very interesting. So what to teach them? What is, let's say, on the level of students who have a certain mathematical training already? So how would we teach them? Do we teach them programming languages mainly, or shall we teach them some specific machine learning techniques? What is your experience in this? What is a good way to prepare them for the real world?
I have some experience and some students that made great career in American and other companies. For example, in Microsoft, at least my one student is very brilliant. So we work with him 4 years, and then he went to Microsoft, and now in 2 years he is already manager, not simple developer or some programmer. And I think about his way. The main point was that I did not lean it in detail what to do. I just put the problem, describe the possible decision, and he's find the ways to solve them. And this originality and the not controllability, not very, it is not a very strong controllability on student. We must trust them and must motivate them. If they have a talent, they would have a decision.
I try to summarize it. So you say
machine learning is a very work science. I don't understand how we must to describe some course, for example, as analysis 1, analysis 2, analysis 3, and we may teach them, and we obtain the specialist in machine learning. The machine learning is an art. As any art, his demands a talent. I finished.
I understand this is an interesting perspective also, that it's an art. So when you learn an art, it requires different skills. But art also requires skills, right? If I look at the Dutch artists, they can paint very well. And they do it by themselves. But on the other hand, they need some basic toolkit. So I still would like to also understand what toolkit we can help them to provide to solve these. Is it mathematics? Is it algorithmics, or something like programming skills? Is there some change in the recent years where we see, oh, it's better to teach this or this? Or is it just a meta level of solving problems?
I work at Faculty of Computer Science and Cybernetics in Kyiv National University. And my opinion is we do very simple way. We prepare a mathematician in a wide sense with basic mathematics, with strong knowledge in analysis, algebra, geometry, and so probability and statistics, of course, and the pattern recognition, machine learning, data science, we teach only in master program. After 4 strong preparation in mathematics. In my opinion, the specialist in mathematical machine learning, data science, this is the variance of mathematician.
Mm. So strong mathematical skills are needed.
If you is a mathematician, you may be useful in machine learning, in data science, and so on.
Mm-hmm. Okay, thank you very much. So a strong base in mathematics should be focused even in 2022. I see that many universities have reduced the mathematics from the computer science curriculum, but well, we should be careful to not reduce it too much because it's maybe extremely important.
There are some conflicts in between so-called computer scientists and mathematicians. Computer scientists don't want to be mathematicians.
Okay.
Why?
Maybe it needs to be motivated to computer scientists that the math is everywhere. I remember that it was for me also the case that I wanted to study more computer science and not mathematics. And why I started to like mathematics was linear algebra helped me to make cool computer graphics. Because you need to use these linear transformations and stuff like this. So in a way, you can also teach mathematics and sometimes motivate it by something that is more tangible to young people. Just a suggestion that I think is sometimes maybe working. Because indeed, the motivation of young students is to study computer science often and machine learning. They want these produce these tools, but then the mathematics, it's not so clear why you have to learn this. But of course, after some experience, you will notice that it's very important to distinguish yourself in the field, to have good math skills. I think also, what is the role of practicals to see real companies early on in the study or in the is this very important, this international company experience? Or do you have any experience how it is done? So we, for instance, give some credit points if a student visits a company to understand how it is different to academia, how the company works, who use some AI technology.
My students works in Microsoft, Intel, Samsung Research and Development, and many others. In my opinion, we more prepare the students for leading company, Facebook, Google, so on. If you see the curriculum vitae of their participants, no? So we will see that the alma mater, Kiev University, they made very strong career in many countries. They have knowledge for this? Strong mathematical skills and very strong programming skills. All they are very strong programmers, very strong. Not users just click in MATLAB and be happy. This is not our case. We write the models for MATLAB, not click buttons in MATLAB.
So real programming skills is a key. I think this
C++, Python, so on. All frameworks and libraries and so on.
Okay, yeah, Michael, I want to emphasize the question number one. There is one thing in my mind. The important things is cloud computing, cloud network, I mean. So we know that Microsoft and Google and IBM, they have machine learning cloud. So I think that's the main important. We can access their cloud. For some case, I can use it free, but you have to pay. But we cannot use our machine. I mean the local machine. So it's better. The key things is we have cloud computing for accessing the machine learning servers, machine learning algorithms that's available in the cloud computing of enterprise companies. I think that's the key topic.
So in a way, it's also that these technologies that are related to machine learning enable us to use machine learning no matter in which part of the world or what kind of budget you have for computers. You can use cloud services, hopefully for a low budget also. And then there is a bigger equality among researchers in the world, which now is a bit biased to those countries, or a lot biased with a lot of budget, who can buy for each one a strong computer. I think this is the interesting thing also to make these. What I think for Q1 is also an interesting answer is about key topics is what we have seen in the COVID crisis and now in the continuation of many crises, that the world can work together on problems using advanced IT in a collaborative way. So in a way, it makes us connected, and there needs to be also tools to make this happen. And when I see that I just changed my background in Zoom, this is, I think, also an AI tool, but I think many things in this online environments are AI technologies. They are based on some machine learning, fast image recognition protocols, and so on. So also signal filtering to make our sound quality good, to make it more immersive experience. It's maybe not just machine learning, it's also IT in general, but I think to make the world more connected and people across borders work together easily and seamlessly is, I think, coming in the next years, and these old-fashioned borders might be a bit more relaxed, and we can work as humans together on problems. At least this is my vision, my optimistic vision. And let's my optimistic vision might not be met by realities by people from the past who want to bring us back to separate. But I think these tools enable it, and I find it very cool that we can make conferences in many countries while not moving. I can be with my family, for instance, which is very nice also, and talk to you. And this is enabled also by smart technologies that are a bit in the background that enable such meetings and such online collaborations. And I think also education. We have seen in this MoMLeT conference many education environments that are supported by AI, that make it more easy for teachers to teach online, to individualize the programs for the pupil to teach them, and also for professors maybe to better grade their exams, which is a lot of repetitive work, and maybe spend more time on individual assessments of students and help and guidance. I think there's a lot of use and connectivity and education, but it requires a different thinking, and that is for me the answer for Q2. I think of distributed systems and networks of people of working together. And it's not so much a single computer who makes one prediction, but more that these tools become part of Internet of Things, of bigger networks, and we don't even notice them so much. So we have tools that are in the background working for us. Not the robot, I think also we will have. We use it already for vacuum cleaning. The little robot, and my mother likes it actually very much because for her it's a big helper. But I think these tools, they are we see them, they are very obvious, but there are so many in the background, so many AI tools, and they also have to work properly or they detect some pollutions that help us to detect the rockets and remove them from the sky when they attack. So I think there are many helpers possible by smart AI.
A few words said about Q2. My opinion that very important is the problem of solving task partly observable Markov decision process. Maybe you know about this. It's a task of sequential decision making, and it's statistics, and it's combined many different fields of IE. And again, in Kyiv exists Institute of Cybernetics. Yeah, every time it starts from Institute of як то буде англійською? Cybernetics. Yeah, but it works only about technical cybernetics. But feedback is field of society too. Cybernetics of society is very important field, and I think that IE should take into account problem of small groups or big groups of society, and the problem of legal problems with як то право і юридичне. Justice, yes. Question of justice too. And we can use IE also to legal tasks and formalize data in this field, and it will help to build such connection and solve many problems that now looks unsolvable, it seems to me. Therefore, IE planning can be applied to society tasks.
May I ask a question to Dmitro?
Yes, please.
Yes, it is a very good point, and the modeling of social economic processes is a very urgent trend of cybernetics. Maybe many methods of artificial intelligence may be applied to this direction, and it is necessary to simulate and to model those processes anyhow. There are a huge bulk of different models in this direction about modeling social process. But the main question is how relevant are those models, how to prove they are relevant, or how to check their relevance. It's a very hard question, and how would you answer this question?
Yeah, but model maybe are not very connected to reality, and the task of solving the problem of POEMDP solving, not solved till now. This partly observable Markov decision process, not formalized, not solved now, and we cannot build real good models. Bulk of different models is not solution. We can build different models, but we should build one, but right one. Not we cannot solve universal problem, but start to solve different part tasks and some particular problems using such approach. And even I said in question 1 about robotics, all these vacuum cleaner, yeah, it's just it's not a real task solving device, yeah. It only plan trajectory to clean,
Yes.
but not more. Yeah, it's not adaptive. And when such robotic system will build some strategy, optimized strategy, and estimate expected utility of strategy, and will teach itself, it will be a real robotic system. It's a future of such technical field. But
I think there are also many applications that go into robotics that are a bit more large scale, like cleaning. For instance, landmines are cleaned nowadays by robots, and they have to be found and cleaned. And there's also pollution that is recycled and found by robots. And so there are many tasks that robots can do, and that require a lot of patience and also intelligence to navigate some terrains.
yeah.
I think the recycling is also a quite complex task. Recycling requires to now people they separate their garbage, organic, plastic, and non-plastic paper, and they make many mistakes because of negligence. And we cannot use these materials. We need some smart systems to filter quickly or detect quickly when people made mistakes in this garbage, and then it is of much higher quality. Like in Finland, they do a lot of paper production, and they need good old recycled paper, and often there's a little bit of plastic still. Robots could probably find out this plastic, but it's still done by humans who sit on a conveyor belt and have to quickly detect some recycle. And I think recycle is a key technology for the future because we have limited resources and we have to spend them wisely. And, there are many technologies also with respect to environment technologies like smart grid. Smart use of power production of various types that require quite artificial intelligence systems and robotics, repairing windmills on the offshore. And then they have these digital twins now. That means you have some simulator of the system that is doing exactly the same things in the robot, but in a simulated environment. So there are many technologies related to this. So Industry 4.0.
It is interesting that Eugene Izhikevich made his $4 billion, namely at vacuum self-driving cleaners in malls and very large buildings.
Is it the same that you mentioned, just Izhikevich? Yes.
Self-driving robots, yes. He made more than one patients and patent and sell them for $25 million and found the startup, and this startup now made with large cleaners.
I think one of the things is when you develop such technologies, even if it's something like a vacuum cleaner, if you put a lot of attention on it and a lot of effort to make it a real high quality product, I think it can be a game changer. Or electric cars, there was some company recently who got very famous for this. And I think the only reason why they got famous was they put a lot of attention on one product. And whatever product it is, if it's something new and you make it very good qualities, and I think you have a chance to make a game-changing application. But I think these vacuum cleaners, for instance, or the robots for the grass mowing, they are a bit, maybe in the beginning they were not so well investigated, and nobody took the effort to use modern machine learning for them. So like Mitro said, they used just simple algorithms, and we could do much better if we really focus on them for a while and use the most modern stuff on them. But I think this deep learning, what it can do is so extremely more than we could do before, that I think there will be, next to autonomous cars, many other game changers in our everyday technology. So that we will experience, and maybe we are the ones who develop it. But I think to fix a product class and do it well, it's, I think, often a good recipe, not to change it every day.
But if
May
you
I ask
look
a
at the
question
book
to
of
Michael?
Goodfellow on the book of Goodfellow in deep learning, the half
Yes.
of this book is clear mathematics. Clear
May I
mathematics.
ask a question?
Yes, please do so.
Maybe to Michael. Anyway, I think that the main trend of machine learning and of artificial intelligence are neural networks. We can do nothing with this, but they are really black boxes. And you mentioned it would be a great idea to make artificial intelligence explainable. And I suppose that the very promising trend of making artificial intelligence explainable is to anyhow combine possibilities of neural networks with possibilities of traditional models of knowledge, such as semantic networks, frames, or knowledge graphs. What do you think about prospects of such a combining of this direction?
In a way, I heard for the first time now that you propose it is there's this idea of explainable AI, but they're not doing this. They are doing actually explanations of the importance of features. So which feature was important for the prediction. And the furthest they go is causal inference. There are some people looking into causal inference now to understand what causes what to. But this ontologies, knowledge models, I think they are not known by people so much who do, let me call it soft AI, so numerical methods more, like using linear algebra operators in these neural networks, convolution, all these techniques. They normally don't work in ontologies or in knowledge representation. So I think it's a very good idea to combine these fields and maybe produce a hybrid that in the right places uses neural networks. I think it's a very promising direction.
Thank you.
Maybe also very new, because I think people just don't work in both fields in the moment so much. So maybe it's very innovative.
Let's consider what we propose to user. We propose to sit in a car without driver and without any knowledge about how it drives. When he sits in such a car, when it will trust to this car, but not knowledge about this car does not make it trustworthy.
Mhm.
I know how drive to car, but I know how many clashing at the ways.
Another case.
No, this is the case of transparency. This is not
When I,
the case of knowledge. Do you know,
when I
know how
drive,
to watch TV? You just watch TV.
when I drive a car, I don't need to know very much about how it works, about how engine works, and so on. I want only to achieve my goals related to driving. But if for example, I'm a director of an enterprise and I have a recommended system, for example, by no, not recommended, but decision support system based on a neural network, for example. Anyway, has been learned. It is able to do something, but I would like to realize how these results were gotten, on the base of which they they have been obtained.
Mhm.
I think it is very important.
Mhm.
Maybe
So also,
I should
The
know not
important is
only
security. Security is the main problem.
maybe I should know not only believe in system, but have possibility to check is it right working. Possible. It's therefore it explainable that checkable is
Yes.
possibility to check.
As far as I know, one of the main demands to any expert system is to an ability to ask it questions why and how it got such a result, such a
mhm.
conclusion. It's
Mhm.
a basic which rules.
But I think the language is often still very much driven by the knowledge of people from more numerical methods, and it's like this was achieved because this variable played a major role, or this feature. This feature is often the reason, but it's not based on ontologies and understanding of natural language and reasoning processes. So I think there was a very good point in our discussions that we should use knowledge. The people who know about knowledge and how to model
Knowledge,
knowledge. We should use more complex systems or more profound systems to talk about the knowledge that this neural network is representing, and not just these primitive things like this feature is important and that feature is not so important. This is explainable
No,
AI right now. I think it's rather disappointing from a point of view what you could do with knowledge modeling. But
knowledge is not necessarily about natural language. It can be in different forms.
mhm,
Well, for example, a little example about system of automated detecting plagiarism. It is easy to pick an example when any system would recognize it as a plagiarism, but actually it is not a plagiarism, but a new result. And how to teach such a system based on neural networks to distinguish when it is really a plagiarism and when it is a semantically new result. I think
mhm,
on the basis of combining.
mhm. And I would also say that the knowledge about what is plagiarism should be explicitly stated in some way. Mm. And it should be reasoned by means of this explicit knowledge that people can revise and check why it is plagiarism. But then there are the indications that I also used in law a lot. In a criminal case, there are some indications that somebody has done something maybe based on some statistics on what previously this person has done, and they can make some indication, but these are not enough to explain. So you need to, statistics can often give us some tactics where to look, but maybe it's not enough to make a decision.
Yeah, of course it is not enough, but it's not about the textual plagiarism. It's about some new ideas, and
yes,
I think it may be rather hard. Textual plagiarism is easy to be detected.
Yeah, and you can also put a warning, says this looks like plagiarism, but ask the human to check it. So
Yes, of course, but it may not work.
But it's also extra effort. In medical diagnosis, there are also systems that in a picture automatically show to the physician the areas that should be investigated in detail because there might be something. And these are systems that support humans, but humans make the decision. So I think such hybrids are also very common. But then it's good if the system can also explain why it points to a certain area or to a certain disease. I think it is this disease because such and such and such symptoms in combination are very typical, something like this. Anyway, I think that the language of knowledge models might indeed be a good thing to look at in explainable AI and not just the importance of variables and features. So, because I find it rather simplistic what is done right now in explainable AI. Trustworthy AI is something, I think it needs explanations, but even more. Also there's privacy and I don't know, trustworthy, maybe. What does it mean, trustworthy? What would we say is a trustworthy AI system? We trust it works, or we trust it does a right decision?
I think that we must use statistical terms in describing trustworthy. When I say that my program make right decision in 95% of 100, it is trustworthy.
But then if you don't know why it makes the right decision?
Why it is not important, because I verifying that I have 25 years experience in medical diagnosis using machine learning and pattern recognition and so on methods in oncology. And when we make some decision, we must reply only one answer, how precision. So 100 cases, how much right answers you made. How do you did it? How did you do this? It is not important. It is interesting for mathematicians, for statisticians, for specialists in machine learning, for medicine, and for especially for patients. It is not important. Well, magnetic resonance, MPI, so tomography. Has a patient knowledge about radon transformation? Radon transformation is a mathematical basis of computed tomography. We see some scan of tomography. This scan made of some tool. And we see some magician who comments this scan. But all this made by mathematicians. Mathematicians made radon transformation and make some photos. Patients cannot and may not and don't any about radon transformation. He see in eyes of magicians and ask how much I will live.
It's a more deeper level. What might be really important
and
are
mathematician
indicative features.
Speak not long.
So
and anyway, statistics sometimes doesn't work. For example, if I never died before, it anyway doesn't mean that it will not happen in future. So.
Oh, you're getting very philosophical. Yes, indeed.
There are different levels. What is different not about radon transformator, but about some indicative features.
But I think it's also to adapt to new situations. We need knowledge to predict situations in which we have been before many times. Maybe statistics is enough. Something like this.
In my opinion, statistics enough.
I think it's enough if we have situations that reoccur. It's a frequentist.
Frequentist. I'm frequentist.
Okay. Yes.
Sometimes it doesn't work.
Anyway, I would like to leave this discussion. We can also think about it ourselves. Do we need? Can we trust completely the frequentist approach, or do we need insights into why certain predictions are made? I would argue personally that I think it's when we have a new situation that we have not seen before, it's good to understand the mechanism. But if things are reoccurring many times, our past experience can be used to train some machine learning model with a high accuracy, because we can use this past as a training data and validation data with all these techniques. And anyway, I think then it's if we want to explain a system, we need a more rich knowledge, possibly. And this was this idea to use ontologies. Who needs to explain a system is another question. The one who applies, maybe not, but maybe the one who develops or who is just interested or curious in getting insight into a domain, like the engineer who would like to get insights from the simulation and not only output value, to think actively. Yeah, so there are many possibilities of thinking and schools. I think looking at the time, we are almost at the end of the panel discussion. I think there were many interesting points. We moved a bit along the different questions. And the chat, we have put some messages. I can maybe copy them. And because when we close the chat, it will be lost. These also point us to some researchers who do some interesting studies, like Izikevich, and some names of programming languages for children. So I see that we had also some new insights. I would like to look up Industry 5.0. What is the new? What is this new standard? I think some people already talked about Industry 5.0 in this workshop. And then we talked about trustable AI and explainable AI, causal inference and knowledge systems, how this relates to each other. And I found it personally a very great idea to combine knowledge models from the school of knowledge modeling and ontologies and so on with AI systems. Maybe also an opportunity for our conference to look at such things, because we have both researchers represented. There were people in ontologies, like Metro is working a lot on this, I know, and many people more from a statistical approach. Okay, maybe some final comments from you. You would like to mention something, please. And then I would like to close MoMLeT, or we, Metro and me.
I propose the decision. We must to develop interesting AI for young men, explainable for middle-aged men, and trustable for old man.
This is a very, so what you said was for the young men.
Interesting AI.
Interesting for young men. Explainable, and then comes trustworthy for.
When we're young, we look interesting things. When we middle age, we desire to understand. And we are old men, we must trust.
Good.
I believe.
Metro, do you have some final comments, or you want to for our discussion? No, for MoMLeT we will.
I think that IE is very important in our very fast changing time, and should be applied in different fields, not only technical, but other too, economical, social, and so on.
Okay. Alexei?
Well, it's hard to add something. Anyway, I think that the main trend is neural networks, which simulate подсведомости, something under our conscience. I don't know how to say it in English. But I think more traditional approaches such as data mining or naive Bayes classification should get further development, as well as modeling of behavioral aspects and multi-agent modeling.
So a more balanced consideration of various techniques. Thank you. Vadim, would you like to contribute some final
Thank you.
comments?
I full support Alexei approach. In my opinion, in future MoMLeT's conference should be more activity in area of neural networks such as mathematics, architecture, and using technical hardware. It's my
hardware.
Yes. Over.
Thank you. And Miroslava, are you still online? Ekaterina? Sechivan?
Yeah.
Okay.
So
you can.
I'm just listening.
Just some final comments on the future.
This conference is quite good. I mean, it's talking about modern machine learning. So I tried to figure out what kind of modern machine learning. So, but it's quite interesting because we are facing the new world of, we just discussed robotics, automatization, human brain interface, probably connectivity between a machine and human. And it's very, for my opinion, it's quite a kind of very interesting to discuss. So probably if there is another opportunity to to do a next conference, I would like to contribute probably with my students, my colleagues, to give papers. I hope the attendees is more than now. That's in my mind. So I can have a wider information about modern machine learning. That's
Okay.
my
It would be actually also very nice in the context of the development of this workshop, which started in a more local workshop, and we are intending also to expand worldwide this workshop to open to scientists from also. It would be very nice if you keep interest, and we will keep you informed about the next year's edition. Okay, so I think who else wanted to say something? Please open the microphone. Otherwise, I would like to say with Metro some closing words for the conference.
You propose to close conference now or according to our program?
Yeah, it's a good question because we can better stick to the program, right? If somebody wants to join.
Yeah, maybe.
But I'm not so sure if people will still reconnect.
We need 5 minutes. 6
5 minutes, yeah, then we can stick to the program. And we need also maybe a small break. We had a quite long discussion, which was nice. I enjoyed, but I think it's, I summarized everything in the chat, so please keep the chat open for a moment. I will make a note for myself and then send it to you, and we have to see how to share it with the participants. Maybe we can make a very small report, but I'm not sure exactly who said what, and maybe we should keep it for the MoMLeT conference. Just some summary of some key points. I can prepare it and send it to you, Metro, and you can tell me then if you want to add something, maybe.
You are prepared,
also,
okay.
Yeah.
Because I don't know.
I did some notes during the discussions that we see here, and also who mentioned some important topics. But I also missed many things that I didn't note. So I will make a summary for this discussion, and then we can share it.
I have only very general impression.
I sent via chat an address of Izhikevich site.
Yes,
where
I have it.
he described his research.
Okay, I will note it. And your name is that. Can I say that you propose this direction? So, but I can also, maybe I leave it like just a general discussion and share with us. Thank you. I will just copy the chat and send it to us. I will do a mini break and then I will come back. Metro, is there something planned for the closing ceremony? Or is it just a general say goodbye and remarks for the next conference? He's also taking a break. So I will also take a small break. Hello, yeah. Shall we stress something important for the closing ceremony? You are muted.
Nothing specially important, but few words. That's all.
Yeah, we can also remark that next year we plan again, hopefully,
of course,
hybrid format, at least.
I hope.
Okay, be right back.
Yeah, yeah. Break, short break. I asked Vasil Litven.
Okay, so we can start the closing.
Yeah, I asked Vasil Litven to come, but he said that only 2 hours per day has electricity now, has not, and he asked to sorry for not participate.
So maybe we can share the questions that we had in the panel discussion. We can still leave them on, pointing to the future a bit.
Let it be.
Would you like to say a few words about MoMLeT past and future?
Me?
Because
yeah. Dear participants, I'm very glad it had been possible to organize and fulfill this workshop. It's a tradition already 4th in line. We hesitate in the start of this year to do this workshop or not, but at the end we decided to provide it, and it seems to me it was successful. Many reports, 28 reports, some better, some worse, but in generally interesting, very different, and it helped us to increase level of investigation and maybe in future level of reporting. language and to meet each other. It's for me very interesting. Many reporters from Kyiv and Kharkiv, as usually. It's very strong reports from there. And these conditions is unique when somebody a few days without electricity and come here in our workshop and reports 2 times already. Dr. Professor Dmitro Klushin. And I thank very much for everybody who participate. We also at first this year prepared all video presentation before conference, and everybody can look all our presentations on YouTube. They are combined in one line with numbers and in the same same order. We can see one by one all these presentations. I don't know how it will be next year, but I hope that in spring, end of spring 2023, we will prepare a new workshop and ask everybody to participate in the future and do wider conference and workshop and ask everybody to advise maybe how to increase or do it better, maybe longer reports or shorter reports or something for improvement. Please make your proposals. We are ready, of course. And sorry for any inconvenience. We try to be better time to time. Thank you very much.
Thank you very much for your great work. This was very interesting workshop, and Michael and Dmitro, I very thankful.
Thank you.
Thank you. I also would like to thank all the active participants for their contributions, and also the ones who attended now the panel, and especially the ones who prepared the keynote presentation. They were great presentations that give us a good up-to-date understanding of some key areas in machine learning, and we hope that we can next year also increase further the level of this workshop towards an international event, so to attract more people from other countries, but also from Ukraine. Many people, it is a very interesting to workshop under difficult conditions. And we heard already in the panel discussion from Sechivan Hadi, who for the first time attended the workshops, that he will help us promote also in Asia this workshop, and there's a lot of interest in modern machine learning technologies. So, and we would also be happy if you can help us in assuring the quality of this workshop. There's a hard review process, so all the participants who presented in this workshop had to pass reviews, and it's a CEUR certificated workshop, so it will appear in the index DBLP, for instance, and Scopus. So we need to certain quality, and there will be people who check whether we do it, and in that way your paper and your contribution, your report is more valued. It's a citations that is accepted for an international conference. But to achieve this level, we need also people who help us with reviews. So we would at a certain point also contact you to, if you are qualified to help us with these processes. And some of you did, and thank you also for this, the people who attended the program committee. Okay, I would like to say that for me it was making me aware of this workshop, how good it is to have electricity. So we take it for granted, and when you not have it, it's improvisation is much needed. And I see also I got this feeling that this is I'm looking forward to the next workshop with this community of researchers and looking for modern trends in machine learning to look for the future and for good applications in this direction will be something that should remain the theme of our workshop for the as I said, one has also pointed out, this is modern machine learning and data science. So we are focusing on the new trends and looking to the future, which hopefully is good. Thank you very much.
Especially thank you, Michael Emmerich, because he is initiator of all these workshops to be
be together with the Lviv team. So
we only support your idea.
We are doing it together. And Victoria Vitosha also helps a lot.
Also thank you, Victoria. Yeah, we have good team. Thank you.
Thank you.
Thank you.
Good.